Hi folks, we're going to look at a sample old AP question and kind of talk through it and help use it to think about how we could be asked questions about kinematics. So this is from the 2012 AB exam, and it says for 0 is less than or equal to t is less than or equal to 12, a particle is moving along the x-axis. The velocity of the particle at time t is given by the equation you can see here. Velocity is equal to cosine of pi over 6 times t. And they also tell us the initial conditions that x equals -2 at time t equals 0. And so for 0 is less than or equal to t is less than or equal to 12. I'm missing the rest of this here. When is the particle moving right? Or sorry, to the left. Well, we know that if we have our velocity, we need that to be equal to a negative value to be moving to the left, right? Because left on the x-axis is negative. So we want this to be less than 0. Well, how do we figure that out? We figure out when it's equal to 0. That'll tell us when it changes. So start by saying cosine pi over 6t is equal to 0. That implies that pi over 6 is equal to the inverse cosine of 0, pi over 6t, which will equal to t equals to 3 and 9. You can go through and play with that on your own, but basically we look at cosine of when is cosine equal to 0. We write out a couple of those, then we say, okay, multiply that by 6 over pi and find the values that are between 0 and 12. If you need help with that, call me over in class or ask me about it and I'll be happy to help. Anyway, but for t, we get 3 and 9, and then we just look, okay, what values of cosine are negative? We know that cosine starts positive at 0 and then goes negative at pi over 2 here. And so when we plug in 3, that's pi over 2. So we know that it's between 3 and 9 that we have this negative on our curve. So therefore, 3 is less than t is less than 9 is our interval where the particle is moving to the left, because that's where v of t is equal to a negative value. For part B, same setup. It says, write but do not evaluate an integral expression that gives the total distance traveled by the particle from t equals 0 to t equals 6. Well, we know that if we integrate from 0 to 6 of the velocity, that will give us the displacement. That'll give us the total change in x. But we want not the displacement, but the distance, which means we need to look at, we want to have anything that was negative. We don't want that to counteract our positive motion, right? If I move to the right and then I swing back, I don't want that to counteract. So what do I need to do? I need to take this part that I swung back and make it positive and just add it on up here. So in other words, what I need to do is take the absolute value of the velocity. And so that's all this one is the absolute value of the integral from 0 to 6 of the velocity function. Part C says, find the acceleration of the particle at time t. Is the speed of the particle increasing, decreasing, or neither at time t equals 4? And explain your reasoning. Well, we know that acceleration is the derivative of the velocity with respect to time. So in this case, it will be negative sine pi over 6t times pi over 6 because of the chain rule. And if we find a of 4, Well, 4 pi over 6, that's going to be in a region that has it less than 0. So this is going to be less than 0. Because this is all that we care about is that it's negative. V of 4, if we check that out, we know that this will also be less than 0, because we saw previously it's negative from 3 to 9. So in other words, if both of these are less than 0, and if you're not sure on this, you can actually plug it in and double check, but since both are less than 0, it is speeding up. So because both acceleration and velocity are negative, therefore this particle is speeding up. If they were opposites, it would be slowing down. If they were the same but both positive, it would be speeding up. And the only way that would be neither is if a equals 0. The acceleration equals 0. It's not speeding up or slowing down. The rate of change of velocity is 0. And then lastly, part D says find the position of the particle at time t equals 4. Well, we know from earlier that the position is equal to the initial position plus the integral from the initial time to the final time of v of t dt. So x is equal to the initial position, which we know is -2, plus the integral from 0 to 4 of v of t. That's just a simple u substitution integral, so I'm going to skip over doing that. If you need help working it out, let me know. But it's going to give us 6 pi sine of 6 pi t integrated from 0 to 4. And I'm going to skip over the algebra because I'm hoping at this point you're comfortable with it. If you need help or support in working that out, though, let me know. But if you do that, which I would encourage you to try just for practice, you should end up with x equals -2 plus 3 square root 3 over pi. And this is all stuff you should be able to do without a calculator, kind of by hand, plugging those things in. If you have any questions, let me know, but otherwise that's an example of kinematics with calculus from the old AP exam.